All right, so right now it's 8:39 at night, and honestly, I just feel like doing another circuit, so I'm going to go ahead and pull this one up. Before we just did a parallel circuit, so now we're going to do one with the voltage missing, and they give us the initial current and the values for the resistors. So just like before, I'm going to pull this up on my iPad, and we're going to work it out. All right, just having some problems with my computer, but that's fine. Swapping over to my iPad. Let's see. So we have a series circuit. No. We have a parallel circuit now with an unknown voltage. We're going to have three components. Let's fix that. That's going to be our first resistor. That's going to be our next resistor. And here's going to be our last resistor. What we do know is the current going through the circuit. I in and I out. It's going to be 2 amps. R1 is 1k ohms. R2 is 2.5k ohms. R3 is 5k ohms. So, like before, let's just have our VT, IT, and RT, and our PT. All right, looking at this, we don't know the voltage. However, what we can do is solve for resistance total. And we could do this by taking the sum, the inverse sum of each inverse resistor. So in the previous video, I showed you guys the calculation to do that. However, if you guys want to pause the video now, I'm just going to do the calculations. It's going to be the inverse of 1K plus the inverse of 2.5K plus the inverse of 5K equals the inverse of X. Let's just have it as X. So, plugging that into our calculator, we have 1K, 5K, 625. So that's going to be our RT. 1K, 2.5. All right. Now we know what our IT is. It's 2 amps. So since we know IT and RT, we can find VT by multiplying 2 amps into 625 ohms. So this is just following V over I times R. And I recommend before every test you just write this here because it's going to come in handy a lot. So what do we want? We want to find our voltage. So we can just cross out that, and it leaves us with I times R. So 2 amps times 625 leaves us 1,250 volts. And that's going to be going through our entire circuit. Or we can write it as 1.25 k ohms. No, volts. All right, now finding the current, let's just cover current up. We're going to divide voltage and resistance. So we know what that is, 1.25k volts, and dividing that by 1,000 resistance equals 1.25. amps. 1,250 volts divided by 2.5k resistance equals 0.5 amps. And 1.25k volts divided by 5k ohms equals 0.25 amps. And this just all adds up to IT, so we know that's right. And now we could just go ahead and find PT. And PT, as we said before, is V times I. So 1,250 times 2, 2.5k watts. 1.25 times 1.25 equals 1.5625 watts. 1.25k volts times 0.5 ohms. Oh, I'm saying ohms. I mean amps. Equals 625 watts. And 1.25k volts times 0.25 amps equals 312.5 watts. All right, so just doing our addition, we have 1.5625k watts plus 625 plus 312.5. Let's just put that in a calculator. That's going to be equal to 2,500 watts. And that's our answer. So you see, it's all just about configuring your circuit and pulling out what you need. And there you go.